We're going to be doing Chapter 5 worksheet today. So Chapter 5 is all about alkenes and nomenclature and some properties of alkenes. So remember, alkenes are when you have double bonds involved in your carbon chain. So alkenes can also be called unsaturated hydrocarbons. So if you remember from the past few chapters, alkanes are called saturated because they're completely saturated with hydrogens. When you introduce a double bond and you have an alkene, you lose one hydrogen from each side of the double bond, basically, so that's why they're called unsaturated hydrocarbons. The formula for alkenes is going to be CnH2n. If you remember, the formula for alkanes is CnH2n plus 2. And so, like I said just now, when you introduce an alkene, a double bond, then you're going to lose one hydrogen from each side every time you have a double bond. So that's why you don't have this plus 2 here anymore. The hybridization of alkenes, so talking about the double bonded part of the alkene, is going to be sp2. And if you remember, the bond angles for sp2 are 120 degrees. Okay, so elements of unsaturation is something they introduce in this chapter. Basically, you can take a formula, they'll give you a chemical formula, and they'll ask you how many elements of unsaturation. So it tells you a little bit about the molecule and what it might look like. So an element of unsaturation can be a double bond or a ring or something like that. So anytime you're basically losing a couple hydrogens. So basically all you have to do is take a formula that they give you. For example, we're going to do this one first. So that's C14H26O3. So you just take this formula and then you just plug in the numbers for each of these corresponding things. And X is any halogen, so fluorine, bromine, chlorine, and it's pretty straightforward. So go ahead and pause the video and do this, and I'll show you the solution in a minute. Okay, so to determine the elements of unsaturation for this, you would plug in 14 for carbon. So 14 plus 1 minus 1/2 times, there's 26 hydrogens, and there's no halogens. Plus 1/2 times the number of nitrogens, which is 0. So what we get here is 14 plus 1 is 15, minus 1/2 of 26 is 13. 15 minus 13 is going to be 2. So you have 2 elements of unsaturation. That's all that this formula can tell you. It won't tell you whether one of the elements is a ring and one is an alkene or anything like that. So that's basically all the information it gives you. Go ahead and do the example for this one. All right, so this is C8H13Cl3. Go ahead and pause the video and do the elements of unsaturation for this. Okay, so we're going to have 8 carbons plus 1 minus 1/2 times, so hydrogens we have 13, minus the number of halogens, so that's 3 halogens, plus 1/2 times 0 nitrogens. So you get 8 plus 1 is 9, minus 13 minus 3 is 10, 1/2 of 10 is 5, so you get 9 minus 5. Uh-oh. Okay, I just found a mistake. So, sorry guys, this should be H plus X. So that should be 13 plus 3. Sorry, so this is 9 minus 16. 1/2 of 16 is 8. So 9 minus 8 is going to be 1. Sorry about that, guys. So go ahead and fix this on your sheet. That's going to be plus. If you have the worksheet, it's written correctly. I just wrote it incorrectly just now. All right. So there's some physical properties for alkenes. You guys can go ahead and review those on your own. I'm going to go over some of the nomenclature now. So for alkene nomenclature, there's a few new things. So the first thing is that the suffix is going to change from ane to een. So basically your suffix is going to be ene rather than it being ane. The other thing is that you're going to make sure that your root chain includes the double bond. Regardless of, you're going to find the longest parent chain, but it has to include the double bond. So how can that make a difference? So for example, if you had something like this. I'm going to actually make this longer. Okay, so if you had something like that, when you automatically look at this, you would say, okay, that's the longest parent chain. But since there's an alkene, you have to make sure that this alkene is included in the root chain. So you're going to find the longest parent chain that includes the alkene. So for this, we would either be looking at this or this. So counting, you would have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. So this would be the parent chain going from here to here. For numbering, you also want to give the alkene the lowest numbering possible. So for this, we would start here, 1, 2, 3, 4. Okay? And then pretty much everything else is going to be the same. If you have 2 double bonds, you're going to use this as your suffix. Adiene. Okay, so di for 2 bonds, 2 double bonds. And if you have 3, you would use a triene. Okay, so that would be your suffix. You would name it as normal. Instead of putting ene, you would put a diene or a triene. Okay? All right, so the last thing that's important for naming alkenes is determining E and Z. So E and Z is a new concept that is introduced in this chapter. And the reason why it's necessary is because, so basically we're going to be looking at alkenes. And if we looked at an alkene like this, you could label this as being cis or trans, right? So you would say that this is trans and that this is cis, right? But let's say we get things a little bit more complicated than this. So let's say we had this also on this bond, or this also on this bond. Okay? So if you have more than one substituent and they're different substituents, so if you don't have one substituent and a hydrogen or something like that, you have to use E and Z rather than cis and trans, because when you're looking at this molecule, you can't label cis and trans because what are you labeling cis and trans in terms of? Nobody would know whether you're labeling cis and trans in terms of these or in terms of these. Okay? So E and Z is a new concept, and basically you're going to use your priority rules that you learned for R and S. So you're going to determine priorities on each side of the alkene. So like for this one, this would obviously be the number 1 priority since the other substituent is just a hydrogen. Okay? And on this side, this is 1 carbon attached to it, and this carbon only has hydrogens attached to it, whereas this carbon has another carbon attached to it. So this would be your number 1 priority. Okay? And on this side, you would have 1 and 1 by the same reasoning. Okay, so now instead of labeling cis and trans, you number the priorities and you figure out which side of the bond the highest priorities are on. If the highest priorities are on the same side of the double bond, this is going to be a Z alkene. Okay, and a lot of the professors say, help you remember this by saying Z same side, so if that helps you, that's good. And then if they're on the opposite side of the double bond, you would label it E. So this just goes into your nomenclature. It goes before, like if you were doing R and S, you would put it in those parentheses before the name. Okay? All right. All right, so let's do some examples. Okay, so this is our first example. So we want to make sure that we choose the longest parent name, the parent root, basically, so that we can include the double bond. So the longest one for this would be going across either way. So let's see, 1, 2, 3, 4, 5, 6, or 1, 2, 3. So either way, you're going to get the alkene to start with the number 3. So it'll work either way. I'm going to go ahead and do this. So look at the next thing. So now we have these two substituents. And on this one, I would start from this side because this chlorine group alphabetically comes before a methyl group. So I would start over here and say 1, 2, 3, 4, 5, 6. Okay? Okay, so the root name is 6 carbons, so, and there's only one double bond, so we know that it's going to be hexene. Okay, now we have to deal with the substituents. So we have a chloro group on carbon 3 and a methyl group on carbon 4. So we're going to say 3 chloro, 4 methyl, and then I'm going to write 3 hexene because that's where the location of the double bond is. You might also see this as hex 3-ene. Either one of them would be correct. So what's the last thing we have to include here? The last thing we have to include is E and Z nomenclature. So when you're looking at the alkene, the number 1 priority on the left side would be this one. And the number 1 priority on the right side would be the chlorine. Because a chlorine is going to be better than a carbon. Oh, sorry. Okay, so our number 1 priorities are on the same side of the double bond. So that means that this is a Z alkene. Okay, so the full nomenclature is going to be Z, 3 chloro, 4 methyl, 3 hexene. All right, let's do another one. All right, so I'm going to go ahead and pause this, or you guys can go ahead and pause this and try this one on your own. All right, so for this one, naming the longest parent chain and giving the lowest numbering for the alkenes, you would have to start over here. So you would say 1, 2, 3, 4, 5, 6. Notice that if you had started over here, you would have lower numbering for the substituent, but you would have higher numbering for the alkenes. So you're going to want to go by the lowest numbering for the alkenes first and then work with the substituents afterwards. So this is a hexene. It's a hexadiene because there's 2 double bonds, and we have a bromo on carbon 5. So we wrote 5 bromo, 1, 4 hexadiene. You're always going to write the lower number of the alkene. And then I wrote down E. So let's see if this is E. So the number 1 priority on the left side of the alkene is going to be this group coming down because the other substituent is just a hydrogen. And then the highest priority over here would be the bromine. So those are on opposite sides of the double bond, so this is going to be an E alkene. All right, what about this one? So I didn't write down E or Z for this one. So the reason is because these are both hydrogens, so you can't name one or the other as being number 1 or number 2 priority. So this E and Z only applies when you have different substituents on the carbons. All right, and notice that I didn't write 4E. It's not necessary to write 4E for this one since there's only one that has E or Z nomenclature, but if you had more than one, you would write like 1Z, 4E or something like that. Okay? All right, let's do another. right, go ahead and pause the video and try this one on your own. Okay, so this one's probably the trickiest one, but it incorporates a lot of material in terms of nomenclature that you've learned right up to this point. So it's definitely something that you could see on the exam, something similar to this. So let's go ahead and give the nomenclature. So the lowest the lowest numbering, we want to make sure we have the longest parent chain with the lowest numbering for the alkene. So we're going to start from over here. Okay, so the alkene is right here. And then we have these substituents, a bromo and a methyl. So this is a 6-carbon chain, so we're going to call this hexene. There's only one alkene. This double bond is on carbon 2. Okay, sorry, I'm kind of working backwards. So now you have your 2 substituents to deal with, bromo and methyl. So you're going to put bromo first because it's in alphabetical order. So you would write 5-bromo, 4-methyl. Okay, and are we done? We're not done because we have to name a few more things. So the first thing we have to do is name the alkene, whether it's E or Z. So now for this one, technically you could name this cis or trans, since you have 2 hydrogens on the other, you have 1 hydrogen on each carbon. So you could technically name this a trans alkene. But my suggestion to you is that E and Z will always be correct, and cis and trans will only sometimes be correct. So to be safe, I always converted to E and Z. So for this, you would have your number 1 priority up here, number 1 priority down here. They're on opposite sides of the double bond, so you have an E alkene. I'm going to write this up here. So you have an E alkene. Okay? So now you might think that we're done, but if you remember from earlier chapters, when you have stereochemistry here, and these are chiral centers, you have to make sure that you label them R and S. So that's something that the professors would be waiting for you to mess up on, since it was tested on the last exam. And so just be wary of the fact that all of this nomenclature builds upon itself. So you have to include this R and S in addition to this E and Z. So on carbon 4, you would name them, I would name them numerically. So you can put the E, you don't have to write 2E since there's only one alkene, but then I would write 4 and determine whether it was R or S. So how do we determine R and S? Same way with priorities. So our number 1 priority is going to be this one because it's a carbon attached to a bromine, which is good, and better than a carbon attached to 2 carbons. That's going to be number 2. This methyl group's going to be number 3, and number 4 is hydrogen going back into the page. So we can read this as is and determine whether it's R or S. So this is going in the clockwise direction. So this is going to be R. 4R. And what about 5? So for 5, our number 1 priority is going to be the bromine. Our number 2 priority is going to be this long carbon chain. Our number 3 priority is going to be this methyl group, and hydrogen is coming forward. So hydrogen's our 4th priority. If our 4th priority is coming forward, and this looks clockwise, so it looks R, since our 4th priority is coming forward, it's actually S. So that's just a review of all the nomenclature pretty much that you've learned up to this point, and definitely something you could expect to see on the exams. All right. My last point that I want to make is that a terminal alkene is going to be less stable than an internal alkene. So if they gave you a problem like this on the exam and asked you which one was more stable, you would want to say that the internal alkene here would be more stable than a terminal alkene here. And basically, this area of electron density is going to be shielded by these carbons that are surrounding it, whereas here you have this area of high electron density without anything shielding it, basically. In addition to that, cis is always going to be less stable than trans. So if you have cis versus trans, you always want to pick trans. And the reason for that has to do more with sterics. So here you have this electron repulsion going on, whereas here you've really optimized getting them as far apart as possible. Okay? All right, that's it for the Chapter 5 review. Thanks, guys.
The Teaching Center, UF's Learning Resource Center.